This lecture is on population dynamics by the Department of Community Medicine, International Medical University. This is a graph showing world population growth from year 1750 to present and projections until year 2150. You can see that the world population has been increasing very slightly from 1750s until around 1950s. Beyond 1950s, there was a significant increase in the world population with an estimated 6.1 billion population in year 2000 and is estimated to increase to over 10 billion in 2150 with majority of the population from less developed countries. What is the definition of demography? It can be defined as the scientific study of human population primarily with respect to size, structure, development, and composition and geographic distribution of population. All this is very dynamic and changes over time. Economic, social, and demographic characteristics of the population influence health status of individuals. Population size changes according to fertility, mortality, and migration. Therefore, a population is dynamic, not static. This slide lists down some factors that could affect population growth. Socioeconomic status. As socioeconomic status improves, population grows. Fertility rate. As the rate increases, population grows. Immigration and emigration would also affect the population growth. Contraceptive prevalence rate. As the rate increases, pregnancy decreases and negatively affects the population growth. Quality in healthcare and availability of healthcare. Improvement leads to positive impact in population growth. Next, I will introduce the concept of fertility. There are two terminology that is important to understand. Fertility denotes the actual reproductive performance. Fertility is the opposite of sterile, while fecundity denotes the ability to reproduce offsprings. In other words, it is the ability of a woman to conceive and carry the fetus to term. Fecundity is the opposite of childless. There are indices to measure fertility. They include crude birth rate, general fertility rate, age-specific fertility rate, and total fertility rate. We will look into each indices in more detail. Crude birth rate. The formula to calculate crude birth rate is the total number of births in a given year divided by the total mid-year population of that year multiplied by 1000. Example of the calculation is presented on the slide. Crude birth rate is a common indices to measure fertility. It is expressed as number of births per 1000 population. It is a crude measure because it refers to total population, but only women of reproductive age can bear children. General fertility rate. The formula is the total number of births in a given year divided by the total mid-year population of women aged 15 to 49 years old multiplied by 1000. This is more precise than crude birth rate, but need to be adjusted to reflect the proportion of women in the reproductive age to adjust for the distribution of fertility among childbearing women. To address the issue related to general fertility rate, we could calculate age-specific fertility rate. The formula is the number of births in a given year to women in a particular age group divided by the total number of women in the same age group at mid-year multiplied by 1000. Age-specific fertility rate is not a single number as it is calculated for each age group. These indices captures the different fertility rate among different age group. The age-specific fertility rate rises rapidly after 15 years old to peak in the early to mid-20s and decline to low levels after 40 years. This slide is an example of age-specific fertility rate for Bangladesh in 1974. It shows the rate rises rapidly after 15 years old to peak in the early to mid-20s and decline to low levels after 40 years old. Next is the total fertility rate. It is calculated as the sum of the age-specific fertility rate divided by 1000 and multiply by 5. The number 5 in the formula is reflected by the 5-year age group when we calculate the age-specific fertility rate. Total fertility rate can be defined as the average number of children per woman that would be born to a group of women experiencing the given age-specific fertility rate if they survive to 50 years old. Total fertility rate is the most widely used measure of fertility because it is expressed as per woman, has one index number, and is independent of age structure of the woman in the reproductive age group. This slide gives the example to calculate the total fertility rate. In this example, the total fertility rate was 7.08. 7.08 is the average number of children a woman would have in her lifetime on condition that the given age-specific fertility rates remain the same during her lifetime. Now, I will introduce to you the concept of mortality. Indices to measure mortality include crude birth rate, age-specific mortality rate, and expectation of life at birth. Crude death rate. The formula to calculate crude death rate is the total number of deaths in a given year divided by the total mid-year population of that year multiplied by 1000. Crude death rate is a common indices to measure mortality and is a crude measure. It is expressed as number of deaths per 1000 population. Migration will affect the dynamics of a population. External migration refers to movements across national boundaries, while internal migration refers to movements within a country. So for example, rural to urban. The net migration is calculated by subtracting the number of emigration from immigration. The rate of population growth is calculated by the crude birth rate minus the crude death rate plus the crude net migration rate. Crude net migration rate is calculated by the number of immigration minus migration. In most situations, we sometimes assume that the net migration is 0. With that assumption, rate of population growth equals to crude birth rate minus crude death rate. Therefore, the rate of natural increase equals to crude birth rate minus crude death rate. With the assumption of net migration equals to 0, the population growth rate in percentage equals to crude birth rate minus crude death rate divided by 10. Why divide by 10? The crude rates were expressed as per 1000. Therefore, to convert the percentage, we divide by 10. 1000 divided by 10 becomes 100%. Another way to look at population dynamics is on replacement basis. Replacement is the number of children each generation must produce in order to replace itself. At replacement level, each couple needs on the average 2 children to replace themselves. And strictly speaking, we need to consider only female births. The gross reproductive rate is defined as the number of female babies that would be born per woman in a group of women subjected to current fertility but not to mortality rates. It is calculated by multiplying the total fertility rate with the percentage of births that are female. Net reproductive rate is the number of female babies who will live to reproductive age that the woman bears, given current fertility and mortality. It is calculated by multiplying the gross reproductive rate with the probability of surviving to average childbearing age. A value of more than 1 reflects a growing population, and a value of less than 1 denotes a declining population. A value of more than 1 reflects a growing population, and a value of less than 1 denotes a declining population. A value equals to 1 means the population is constant. The doubling time is a concept which denotes the number of years required for a population to double in size if they go continuously at the current rates. The formula for doubling time is log 2 divided by the population growth rate. A value of 23 years means it takes 23 years for the population to double in size. This slide summarizes the doubling time for different population growth rates. I will now cover the concept of population pyramid. Population pyramid is a graphical representation of the population of a country. Basically, it is a histogram for the male and female category. In developed countries, the pyramid is more barrel-shaped, and in developing countries, it is more pyramid-shaped with a widening at the bottom of the pyramid. This slide shows an example of a population pyramid. It is a histogram with 5 years age interval with the male population on the left and female on the right. This is the population pyramid of Malaysia in year 2000. This is the projected population pyramid of Malaysia in year 2025. And in year 2050. You could appreciate the shape changes from a pyramid with a wide base to becoming barrel-shaped. Ways to measure age, sex structure of a population include the population pyramid, calculating the median population, calculating the mean population, dependency ratio, and also the sex ratio of a population. This population pyramid shows how the shape changed in different eras related to specific world events. Dependency ratio. Dependency ratio refers to the ratio of number of dependents, population age between 0 and 14, and also population age 65 and over, to the total population aged 15 to 64. The formula as shown on the slide. Aged dependency ratio refers to the ratio of the number of aged population, so population aged 65 and over, to the total population aged 15 to 64. The formula as shown on the slide. Child dependency ratio refers to the ratio of the number of children population aged 0 to 14, to the total population aged 15 to 64. The formula as shown on the slide. Let us now explore the factors that would affect disease patterns of a population. Factors that influence disease pattern in a population include demographic transition, epidemiological transition, changing risk patterns, and epidemiological polarization. Let us look at demographic transition. The theory states that a population's fertility and mortality will both decline from high to low level as a result of economic and social development. The decline in mortality usually precedes the decline in fertility, resulting in high population growth during the transition period. Example of demographic transition: improvement in educational status and income, improved public health services, effects of urbanization and industrialization would lead to decline in mortality and fertility with a greater impact on mortality compared to fertility, resulting in population growth during the transition. This graph depicts a typical demographic transition curve of a developed country. Referring to the previous slide, the decline in death rate occurred over a long period of time. In this example, over 150 years. The birth rate decline followed closely by mortality. The growth rates were generally low. The base population was small, with vast land and abundant resources. Majority of the developed countries have completed this demographic transition pattern. This graph depicts a typical demographic transition curve of a developing country. The decline in death rates occurred in short period of time. The birth rate decline followed slowly and not matching by the fall in mortality. The growth rates were generally high. The base population was generally large, but with limited land and resources. Majority of the developing countries are in this transitional phase. This slide depicts the stages in demographic transition. It begins with the pre-industrial stage and go into the transition stage, and next to the industrial stage, and finally the post-industrial stage. A decline in fertility leads to changes in the structure of a population, causing chronic and degenerative diseases to emerge. Demographic transition leads to a change in pattern of risk for certain diseases, for example, sexually transmitted disease, AIDS, obesity, industrial accidents, substance abuse, diet, and also lifestyle. Thank you. Hope you have a clear understanding on the concept of population dynamics covered in this lecture.